طيب بسم الله الرحمن الرحيم. So we started to talk about IP security. We talked about the motivation for IP security compared to the network access security. So we said that network access security is traffic agnostic. It actually tries to secure a physical port or a logical port without having to look at the traffic in any way. It doesn't distinguish between applications, traffic, things like that. In which case, any lack of security on any of the applications can cause very simply the attacker to inject some routing messages into the network, corrupting the entire network infrastructure. All right, so IP security came to try to put some policies, as we will see today, on the different types of traffic. To try to distinguish between the different types of traffic. So of course we can identify application, type of traffic, things like that, and provide some security precautions depending on the type of traffic or depending on the application. So IP security is used to secure either host-to-host, which is like the main functionality of IP as a protocol itself. It provides host-to-host communication or a network-to-network communication, right? So similarly, IP security came to provide security either on host-to-host level or a network-to-network level. So this is the different modes of security when it comes to IPsec. So IPsec provides two modes of security, which is the main topic of today. So IP security provides transport mode security or tunnel mode security. So transport mode security is used solely for host to host. Okay, so of course you have like some kind of a network, and here there is one host. Okay, and this host is trying to send over the internet to another host, which is on another private network. All right, so when it comes to establishing a secure tunnel between these two hosts, okay, so in which case host-to-host communication, the IP header, here in the frame there is like the IP header, okay, and this IP header contains the source IP address and the destination IP address, right? So in which case the IP address that exists in the IP header aligns with the source and destination IP address of the tunnel of IPsec. Okay? So in that case we call it transport mode security. And by that we mean that if we want to build a tunnel host to host, what happens is that we take this this packet, and what happens is that we take the payload, the IP payload, okay, and then we add to this what we call now the encapsulating security payload, right? So we add what we call ESP header. We talked about ESP and AH last time. So we said that IP security comes with two components: the encapsulating security payload and the authentication header protocol. Authentication header, or AH, provides authentication part, right? And we said that in IPsec version 1, we had those two components separate. So ESP provides encryption, whereas AH provides authentication, right? And in IPsec version 2, okay, they actually combined, or they merged the authentication as part of the ESP as an optional mode, but they kept AH for backward compatibility, right? So AH in IPsec version 2 becomes optional, right? So going back to the transport mode, so we provide ESP header, which means that ESP will now encrypt this whole thing, will encrypt the IP payload, which includes, of course, any TCP or any UDP or ICMP or any higher layer protocol header. Okay, so it will encrypt the TCP header and the payload. Okay, so this is in the transport mode, and then optionally, we can add the AH for authentication. When we add AH for authentication, what happens is that AH will actually authenticate this whole thing, including the ESP header. And what it does is that it creates the MAC for all this part. Okay? And by MAC here, we mean that we generate a signature for this whole thing, and then we encrypt the signature using some kind of a authentication key. واضح كده? So that's the transport mode. So where is the IP header comes? So the IP header comes after this. So the original IP header, we call it the original IP header. It comes after this. So in which case, in the transport mode, the IPsec works on top of IP header. واضح? Okay? So this is the transport mode. واضح كده? Any question about this? Of course, as we said, AH in that case is optional. In IPsec version 2, AH is optional. But that doesn't mean that authentication is optional. Huh? Authentication must be done. Okay? But it's either done using AH or ESP itself will do the authentication. Any question about this part? واضح. Okay? So this mode provides host-to-host security. Okay? So in which case, all the applications that run on this host will have to go through this tunnel, which means all the traffic will be secure, regardless of the application. So all the applications will have to be secure through that tunnel. واضح كده? So this is the transport mode. Okay? طيب. So so that's why here we say that the protection happens to the higher layer protocols, including TCP, UDP, ICMP, and typically used for a end-to-end communication. So ESP transport mode encrypts and optionally authenticates the IP payload, but not the IP header. So in which case, the IP header, the original IP header is kept exposed, no encryption. واضح كده? So no encryption for the IP header itself. And that makes sense because the routers here, okay, they have to route the traffic based on what? Based on the IP, right? Yeah, based on the destination IP mainly, right? So the original IP header is kept exposed so that the intermediate routers can in fact use the IP header inside the IP destination IP inside that header for routing inside the tunnel. So that makes sense. واضح كده؟ So that's the transport mode. ماشي كده؟ طيب هنا بيقول بقى ايه؟ The AH in transport mode authenticates the IP payload and selected portions of the IP header. That's interesting. So when it comes to encryption, we don't encrypt the IP header. But for authentication, what happens is that we can in fact include part of the IP header when it comes to generating the signature only. Okay? So that also ensures the integrity of different parts of the IP header, but we don't encrypt it. We don't encrypt it. So the intermediate routers will be able to see the IP header and route based on the destination IP. Okay, but it's only for the authentication that we generate the signature for the parts of the IP header, including the ESP and the payload. Okay, so only for generating the signature. Okay كده? Any question about the transport mode? سهل؟ واضح؟
Which part?
Parts, yes, parts of the IP header.
Which part? Any part?
لا هو يعني specific parts. It's detailed in the standards. Specific parts of the IP header. Okay. And when it comes to the IP version 6 as well, which I did not really يعني focus so much on IP version 6 here, because it's much more complicated, and for some of the students, they did not study IP version 6. It's really complicated يعني in the standard. So when it comes to IP version 6, there is what we call IP version 6 header extensions. So basically, IPv6 header may include a linked list of headers. So multiple headers. They call it IP extensions. So all these extensions are going to be encrypted and authenticated. The extensions, not the actual IP header. Okay. But anyway, we're not going to focus so much on IPv6, SIG for IPv6. Okay. طيب. So this is the first mode. In the second mode, we're not actually securing host to host. We're securing either host to network or network to network. Okay, so in that case, we have either like a firewall here and here. Okay, a firewall or a router, and then we build a tunnel between these two routers to provide security from this network to this network, not just a single host. So all the traffic coming from all the hosts on this network will have to go through the tunnel. Okay, so as you can imagine, in that case, the original IP header will include what? Will include the source IP and the destination IP, right? Right? But the tunnel is built between the firewalls or the routers, not the source IP and the destination IP in that case. So in the tunnel mode, it's a bit interesting. But what happened is that we take the payload, including the TCP header and everything, okay? And then we add to that the original IP header, okay? And then after this, we add the ESP and optionally the AH, which means for ASP, all this part is going to be encrypted, including the original IP header. Okay? So the intermediate routers will not see the original local IP and destination IP. They will not see it. واضح? Okay? But they need some kind of IP for routing, right? So what will happen now is that after we include the ESP and the AH headers, okay, for encryption and authentication, we will add another, what we call outer IP header. This outer IP header will include what? Will include the IP of the routers at the beginning and end of the tunnel. Will not include the local IP and destination IP. Okay? Will include the IP of the routers. طبعا the router ports that are part of this tunnel. Okay? By doing this, as we said before, this type of transport, this type of tunnel mode, it's used to secure host-to-host or network-to-network communication. And it's mainly used for مثلا building a intranet between multiple offices geographically distributed over the internet. Okay, so it creates some kind of a secure tunnels over the internet. Okay. Okay, so this is the tunnel mode. So in which case, when one or both ends of the security association are security gateways, by security gateway here we mean like it's a generic term, which indicates firewall, router, okay? Anything that's used to secure an entire network, not just one host. واضح? So ESP, we'll talk about the security association, what that means. Okay? Security association is like a security context, okay, that includes all the information related to securing that tunnel. Okay, so we'll talk about that. So ESP tunnel mode encrypts and optionally authenticates the entire inner IP packet, including the original IP address. So even the original source and destination IPs are not going to be visible anymore. Okay? And AH in the tunnel mode authenticates the entire IP and selected portions of the IP header. Similarly. واضح كده? Okay? Any question about this? This is very important. يعني. This is the core part of IPsec. طيب, so that table kind of summarizes what we have talked about. So, so one thing to notice here is that both AH and ESP, they can be used either for transport mode or tunnel mode, which means I have 4 combinations. I can in fact use ESP for transport mode and AH for tunnel mode. So the standard itself allows all types of combinations. Okay, I can use ESP for both tunnel and transport. I can use AH for both tunnel and transport. I can use ESP for tunnel and AH for transport, or the other way around. Okay. So that table summarizes this. So AH, as we said, authenticates the IP payload, and selected portions of the IP header. And in case of IPv6, it authenticates the IP header extensions. These extensions, IPv6 extensions, and if you go back to network 1, we'll see that we have what we call, it's a field inside the IPv6 header. It's called next header. And this next header, in fact, points to the next header in the protocol data unit. So that next header might actually be a pointer to a linked list of headers. It's pretty complicated, yani. So you can include multiple headers. We call it header extensions. Okay. So in that case, these header extensions are going to be encrypted and authenticated, both. Okay. So so for the tunnel mode, it authenticates the entire IP packet, including the original IP header, and plus selected portions of the IP header and the outer IP header extensions. Of course, AH is included for IPsec version 2 for backward compatibility. So ASP, in that case, provides only encryption. Okay? So in that case, it encrypts the IP payload and extensions for IPv6. And for the case of tunnel mode, it encrypts the entire IP packet, including the IP header. And there is, of course, a mode which is ESP with authentication. So that's only available for IPsec version 2. So in that case, there's no AH header at all. So we have only one header, ESP header, that includes both encryption and authentication. Okay? Okay, so
combinations of AH and ESP.
Right.
I assume that the combinations is because that the packet itself might go through both tunnels at the same time.
Right. Yeah. By that I mean, in fact, there are multiple logical tunnels, and these logical tunnels, in fact, might be recursive. You might have a tunnel inside a tunnel and so on.
Nested tunnels.
Nested tunnels, yes, exactly. You will see that. You will see that at the end.
What's the point of that? This is overcomplication, right?
Not necessarily. No, not necessarily. In some cases, yes, this is in fact is being used. We'll talk about some examples. It's quite similar. So this is the main architecture for IPsec. So that shows the overview or the high-level picture of the IPsec architecture. So it starts here with what we call security policy database. This security policy database stores all the policies for that we apply for the different types of traffic or application. Okay, we can identify a traffic by different criteria. We can identify an application. How would we identify an application? We identify an application by a
application layer protocol, like HTTP, SMTP.
Right, but a specific application instance we identify by the port. Okay, by the TCP port or the UDP port, right? So we can provide a policy based on a port, which means that we identify a particular we apply a policy on a particular application, or we can apply this policy on a particular type of traffic, like all the TCP traffic, or we can apply this policy on a username, all the traffic coming from a certain user, or we can apply this policy based on an IP address by any combinations of the local and destination IP address. So any kind of policy, we'll talk about this criteria in details. So these policies are stored. So what happens here is that this is the main entry point for any type of traffic. So when there is any, we call it outbound traffic. Outbound is any traffic that's going out to the tunnel. Okay? So any traffic that's going out to the tunnel, okay, we first check in the security policy database. We have to have a match for any traffic that is coming in this policy database, okay? So we have to apply certain criteria to say that, okay, so I have a row, one row in the security policy database that matches this traffic. If there is no row that matches this traffic, then we discard that traffic, okay?
Discard or
Discard.
the
Discard.
traffic will
Discard.
be sent?
لا discard. لا discard. We'll talk about the scenario that you mentioned. So, so in that case, if we find a match, then there will be some kind of identifier. We call it a security association identifier. So this identifier will then point to the security association database. In the security association database, we find all the details about the security context for that particular traffic. Whether this particular traffic needs to use specific algorithm for encryption, a specific algorithm for authentication, what are the keys, everything will be stored in this security association database. Okay? So we apply the policy, and then if this traffic is to be secured through the tunnel, then we get the information from the security association database, and then we apply this security association on the traffic, which means that we start to add the ESP header, AH header, and so on. And in this header, we'll see what it actually contains exactly. ماشي? Okay? Which means that by consulting these two databases, we have what we call IPsec security association pair. Okay? One security association is used for one direction, and another security association will be used for the other direction. We'll talk about why we do this. Okay? So there is a security association pair that gets established, right? And based on that, we apply the ESP header and the AH header to establish the tunnel itself, whether it's in the transport mode or in the tunnel mode. Okay? Type. So how do we construct or establish the security association itself? Okay? So that requires user authentication and key distribution, right? So this is done from the IKE or the key exchange. Okay? So if we cannot find an entry in the security association, not in the policy database, in the security association database, this means that this traffic was not assigned a security association yet. Okay, so in that case, we have to go to the IKE or the key exchange server to establish user authentication and key distribution. واضح? Once we do this, then we create a security association, we store it in the database, and from now on we use that by security association for protecting the traffic. So that's the sequence, okay? So one thing to notice here is that only for IPsec you find that there is like a security policy database and security association database and so on and so forth. So when we study مثلا TLS in the TCP layer, you will not find TLS actually using any kind of database and policy database. So why is this? This is actually because for TLS, it actually secures application to application. But here, we have to secure all the applications from a particular host or all the applications coming from all the hosts on a particular network, right? So that's why we need to have we need to establish these databases to include all the security contexts of all the traffic that is coming from this network or this host. واضح كده؟ In TLS, we don't have to do that because we actually secure one application only, one application endpoint only.
Which is one policy only.
Yeah, which is one policy basically. Okay. Any questions here? واضح السيكون؟ أيوة.
Doctor, in the previous slide mentioned that we have.
But that's a good question. Okay, so what is a security association? A security association is a one-way logical connection. Okay, so why one way? Why do we talk here about one-way logical connection? That's related to the inherent features of IP. Remember, IP itself is connectionless and it's unreliable. Okay, so you will see all the features that we will talk about in IPsec here, they are aligned with the main fundamental features of IP, which is the fact that IP itself is connectionless and it's unreliable. عارفين الكلام المفروض. You remember this المفروض يعني. Okay? So that's why the security association itself is one way, because there's no connection. Right? So in TLS we'll talk about something called TLS, I mean يعني security from the transport layer. So in that case we will encrypt what? We will encrypt the payload but not the TCP header. Okay? So in that case it's application to application, right? And in that case we don't need to, there is a connection, right? TCP underneath TLS, it actually maintains a connection. Right, so in that case, the security context is in fact bidirectional. واضح كده؟ So the security association here is one-way logical connection between a sender and a receiver that affords security services to the traffic carried on it. ماشي واضح. In any IP packet, the security association uniquely identified by the destination address. This is in fact what's in the header. What's in the header is, okay? So in the ESP header, you have to have what we call security parameters index. So that's the identifier for a security association. That has to exist in the packet, in the header. So if I'm receiving a packet, okay, and I need to know how do I process this packet, okay? For example, I have to decrypt it, right? I have to authenticate the packet. I have to generate the MAC and verify the packet and so on. How do I do that? So I have to read first and foremost the security parameters index. The security parameters index in the packet will point to the security association database that contains, so this is like the primary key that I use to go to the security association database and fetch all the security context information related to that particular traffic. Okay, so this will help me back to authenticate the packet, to decrypt it, and to process everything. Okay. Also, there is what we call security protocol identifier. That also exists in the ESP header, or it actually indicates whether this is an AH header or ESP header. So it's like a flag. So it's a flag whether this is an ESP header or AH header, because again, the location of the ESP or the AH might exist in different places. So you have to identify what type of header is this, right? And of course, the IP destination address, which is stored in the outer IP header or in the original IP header in the case of transport modes. واضح? So these three values, they exist in the header. So I can fetch these values from the packet, from any packet. And this way I can identify whether this is AH or ASP, and I can fetch all the security association, which contains all the security context from the security association database, from this security parameters index. واضح كده؟ طيب. So what does this security association contain? So this security association contains, of course, the security parameters index, which, as we said, is the primary key, okay, that points to one and one only security association. And there is sequence number counter. Why do we need this? Why do we need sequence number in security in general? هتفكر؟ اتكلمنا عن الكلام ده. برافو عليك. Yes, ده الناس اللي صح. Yes. So security, sequence number counter is used for mitigating replay attack. However, بقى, interestingly speaking, in IP, just using sequence number is not enough. Why? Again, because
Sorry.
تفضل قول. Asynchronous? Yeah, that's partially true. It's actually, that's because of the fact that IP is unreliable, okay, and it's connectionless. So IP packets might not be received in order. There is no order guaranteed, right? And there is no actually guaranteed delivery خالص. IP itself is unreliable. So I may actually receive one packet and then third packet and then the fifth packet and then the 10th packet. I can receive things unordered خالص. Okay? So how do I know? Because in the replay attack we say that, okay, so if I receive a previous packet, then I can assume that this is a replay attack, صح? Based on the sequence, صح? But in fact, IP does not provide ordered delivery. Again, we will see, and when we discuss TLS, things are different because TLS, there is TCP underneath that guarantees order delivery, guarantees connection, guarantees reliability. So TLS, in fact, is luxurious, is lucky because TCP provides all kind of guarantees and stuff like that. So you will see that even for security, it's much easier. But here, it's much more complicated. So for mitigating the replay attack, we need those three, in fact, not just one field. So we need the sequence number counter. We need what we call sequence counter overflow. Why? Because, again, the sequence number is like 32 bits, but it actually has to circulate, right? So again, when I receive something in the past, does that mean this is actually a new packet? Or this is an old packet? So I have to consult the security counter overflow. So if the security counter overflow is 1, this means that I circulated. So in fact, the one with an old sequence number is in fact a new packet. It's not an old packet, right? بيقول لك يعني زي ما بنقول احنا بنقولها كده بالعربي بيقول لك قلب عداد عارف انت العربيه قلب عداد يعني. So this is in fact when the sequence number kind of overflow and it circulates, right? So the sequence counter overflow is also used to identify whether this is a replay attack or not. And there is the anti-replay window. Anti-replay window. Why? Again, because the packets might arrive unordered. So I may actually receive 1 and then 5, and okay. So if I receive 1 and then 5, and then I receive 2, no problem. So that should be okay. صح? صح? So that's why we need to have actually a window mechanism. A window mechanism is not just exclusive for TCP, because we use TCP we use the window mechanism for TCP flow control, صح? But in fact, window techniques are used in different contexts. So that's one of them. But the logic is different. We will see now. The logic here, the function of the window mechanism is not for flow control. Here for mitigating replay attack. Remember, this is the main function. Okay, so we'll see the logic. And for any window technique, we need to have some logic. What if we receive a packet outside the window, before the window or after the window? And inside the window, what do we do? When do we slide the window? What is the event based on which we slide the window? So we'll see that logic and how we do it. So in addition to that, we have either the security association will represent AH or ASP. One of them. So security association either represents AH or ASP, or of course ASP with authentication. So we can have actually one security association that represents ESP with authentication. So in that case, we'll have only one header, okay? And then the lifetime of the security association. Of course, just the fact that there is no replay attack or something like this, it doesn't mean that this security association does not expire, because security association, again, is similar to temporary session security. Okay? So when we perform, we will see, and when we talk about IKE, we perform the user authentication and key distribution, right? Again, we come up with master key, صح? We talked about user association and key distribution results in having a master key. From this master key, I can, in fact, initiate some session keys. These session keys are temporary. Okay? So that's why I need to have a lifetime for this security session. So when this lifetime expires, I have to go back to IKE and re-establish another security association. واضح كده؟ And as we said, we have the flag, whether this is a tunnel mode or transport mode, and we have the path NTU. Path NTU, this is called a path maximum transmission unit. حد فاكر maximum transmission unit is used for what? Maximum transmission unit. Does anyone remember this from Network 1? Maximum transmission unit.
The number of times that I have to transmit the packet?
No, maximum transmission unit. You know, the size of the maximum transmission unit. 1,500. What does this represent, or what is this used for?
The size of the packet.
The size of the maximum size of the frame that can be transmitted over this link. What does that mean? What is this used for?
For segmentation?
It's called what? Fragmentation. Bravo عليك. Yes. Okay. So, yeah. احنا فطرنا بقى. We need to stimulate the brains. Right. So we use that for fragmentation. So by fragmentation, again, for those of you who don't remember it exactly, so if we have router here, and this router is like and the technology used here for network access is Ethernet. For Ethernet, the maximum transmission unit is 1500. صح? So if this passes to a router, and this is a wireless. Wireless, in fact, has a maximum transmission unit less than 1500. So if I receive a packet here with a length of 1500, what do? I have to do a fragmentation. So I have to divide this packet into multiple packets. So that's what how fragmentation works. So what is the problem here? The problem here is that, remember, for IP security, we talk about packets that are encrypted and authenticated. Okay? So when we divide the packet into fragments, this will complicate the process, right? Because you have an encrypted packet, and you have a fragments of the same encrypted packet, and you have like some authentication fields and stuff like that. So it complicates. It doesn't mean that IP security eliminates fragmentation. There is some kind of fragmentation. It can happen. In fact, IPsec provides two modes. Okay? For one mode, it uses authentication, but we're not going to talk about the details. In this mode, we try to avoid doing the fragmentation inside the tunnel. Okay? So how do we do this? While we establish the tunnel between the two endpoints of the tunnel, we try to discover the minimum length of the maximum transmission unit that it can be supported on any link of the tunnel. Okay? So for example, if I have here 1500, and this is like 500, and there's like 3000, and there's like, so which one is the minimum? This 500, okay? So I discover this at this point, and I establish what I call by a path maximum transmission unit. So the path maximum transmission unit in that case is going to be which one? 500. So if I use packets here at the beginning of the tunnel of a size 500, then I'm guaranteed not to perform any fragmentation inside the tunnel. So I avoid doing intermediate fragmentation inside the tunnel. And that's good because fragmentation complicates the process of IPsec. Not to say to make it impossible, it's possible, but it complicates things. So it's better to just establish what we call or discover. They call it maximum transmission unit discovery. Okay, so we discover the minimum maximum transmission unit across all the lengths and store that in what we call path NTU. واضح كده؟ Once we do this خلاص. Any questions? واضح كده؟ So this is what we have in the security association. Of course.
applicable for tunnel or
No, for both transport mode and tunnel mode. Same thing. This is applicable for both. Okay. Again, I'm not saying here that fragmentation is impossible for IPsec. It is possible with some complexity. Okay, and for certain modes they can do it. وبعد كده طبعا AH and ESP here contains بقى all information about encryption and or authentication, including what algorithm is being used, what are the keys, and so on. ماشي كده? Remember, this is not stored in the packet. Stored in the security session database, not in the packet. Huh? I'm not going to store the key in the packet. طيب. أيوة نيجي بقى لإيه؟ Security policy database. As I said, this is the first entry point in the IPsec architecture. So this is where we have to apply these policies on the incoming traffic to see what kind of policy matches this traffic, and based on that, we extract the security parameters index, okay, which is the primary key that we go to the security association database to fetch all the information for securing the tunnel, right? So in more complex environment, there may be a multiple entries that optionally relate to a single security association. So multiple entities here معناها ممكن I can apply the same security association on multiple applications. Okay, so I can have wildcards. So I say all the traffic that is coming from this network, okay, regardless of whatever application, will go through this tunnel. Or I can focus on a certain type of traffic or certain application and apply the policy. Okay. Once I apply applying the policy معناها إيه? This tunnel will be extracted using this security association, which the information for it is going to exist in the security association database. So each security policy database entry is defined by a set of IP and upper layer protocol fields called selectors. So these selectors are the criteria based on which I can match a traffic to a particular policy in the security policy database, and based on that, I fetch the security parameter index, which is the primary key to the security association database. So these are used to filter outgoing. By outgoing traffic here, outgoing معناها outgoing to the tunnel. Okay? يعني معلش this is the terminology that we use. Outgoing traffic معناها outgoing to the tunnel. Okay? In order to map it into a particular security association. So these are by the selectors. Okay? So the selectors can identify the traffic by the remote IP address. Okay? And this may be a single IP address or network address, which includes all the IPs in this particular network. Okay? Or range of IP address. ماشي. Or a wildcard. I can put wildcard to say I don't care, whatever IP address exists. So the latter two are required to support more than one destination system sharing the same security association, which is what we talked about. Or a local IP address, okay? Or a next layer protocol, so I can apply this on a particular protocol. So all the TCP traffic is going through this tunnel. All the ICMP traffic is going, but ICMP doesn't make sense, because ICMP is different. So all the traffic coming from a particular protocol will go through this tunnel. Or a name, which indicates a user identifier. ماشي. Or local and remote ports. Local and remote ports here identify a particular application. Okay? Okay, so just the fact that we have these selectors to select a traffic, that doesn't mean that this traffic will have to use security through ESP or AH. There is one, يعني when we identify this policy, we have to have an action that corresponds to this particular traffic. So the action could be either protect using ESP, ماشي, or bypass. Bypass, okay? I'm not sure if you encounter this, but sometimes you create a VPN tunnel, okay? But when you try certain traffic, it actually bypasses the tunnel. It goes away from the tunnel. It goes through the internet. It doesn't go through the tunnel. Okay, so that has to be defined by or controlled by the security policy database. And we'll see some scenarios. Why would we want to, after creating the tunnel, incurring all the overhead and the complexity of creating that tunnel, we bypass. We have a certain traffic that bypasses this. There are a number of examples that we will talk about that we can have this. And this is actually highlighted here. So for example, we have, so this is one selector. So this is one row in the security policy database. So if we have a UDP traffic coming from this particular IP address through this port, so I'm identifying a specific application or a specific application endpoint going to any remote IP address, going to this, I'm going to bypass. Why? Because this is in fact an IKE traffic. So this traffic, this type of traffic is to establish the user authentication and key distribution. So it doesn't make sense that this goes through the tunnel. واضح? I cannot actually send that through the tunnel because this is in fact being used to establish the security association. So I cannot use the security association to establish the security association. Okay? So that's used for handshaking for user authentication and key distribution. ICMP, same thing. I can bypass because this is used for ICMP, which is like some ICMP messages between the routers which don't have to go through the tunnel. So any IP coming from this application to this or this IP to this IP will go through ESP. Yeah. So this example this is a good example. So any traffic that uses TCP, okay, from this IP to this IP, and from this port, what is this port? حد فاكر? This port is a HTTPS, right? HTTPS, which uses a TLS, okay? Bypass. Why? As you said, because okay, so if it's a TLS traffic, it's already secure through TLS, so I don't have to repeat the job. يعني خلاص. If this application is already secure, خلاص. يعني I don't have to repeat the job. So bypass, okay? There is, of course, some discard. Discard معناها if there is any weird traffic coming from any unidentified source or something like that, then I can discard. Yeah, so or bypass. So I can have any action here. The action might be bypass, discard, or protect, and so on. So this action is very important. Okay. طيب, so for outbound or outgoing traffic, and by this we mean that at the entry point, so we have the entity, whether this is a host or a router, okay? But this is in fact the beginning of the tunnel, okay? And this entity is receiving a packet which will go out to the tunnel, okay? ماشي? So what is the logic? So the first thing, so this algorithm is very important. So the first thing is that we have to search the security policy database. Okay? We have to consult first and foremost security policy database to know what kind of policy applies to this traffic. So if there is no match, then we discard, as I said. خلاص, we have to, that's why we have wildcards. Wildcards indicate some default actions. Okay? So we have to have a match in the security policy database. So only if we have a match, then we have to determine the policy. By determining the policy here, we can have the security parameters index here. Okay? So from the security policy database, we get the security parameters index. This SPI points to, this is the primary key, it points to some field, particular field in the security association database. Okay? So we have to take that to the security association database. ماشي? If the policy is to bypass, okay, then we send it over the internet, which means that we are not expecting to have ESP or AH header. So we just bypass and send it over. So if the policy is to protect, then we have to go through the security association database. Okay, we are supposed to have a match. We're supposed to have a match using the SPI. Okay, if we have a match, then we use that match whether it's AH or ASP with authentication. Okay, and then we add the headers, the ESP, and optionally AH, and then we send it over IP. Okay. If we don't have a match, that doesn't mean that we discard. No. In that case, this means that, yeah, this traffic has not been assigned a security association yet. So in that case, we consult the Internet Key Exchange, or IKE, to establish a new security association database. So we'll talk about this, inshallah, next time. We'll talk about this next time. So this includes what? User authentication and key distribution. Okay, which will go eventually to the security association to be stored in the security association database. So this is the algorithm for the outbound traffic, the traffic that is going into the tunnel. ماشي كده؟ طيب, now the traffic is coming from the bottom layer from IP. It's coming from IP. At the exit point of the tunnel, whether this is the host, the ultimate host, or a router. Okay. So if the packet type, if it's IP, this means that originally the policy for this traffic was supposed to be bypass. Okay. So we have to go to the security policy database and make sure that indeed the policy or the action assigned to this particular traffic is bypass. Okay? If not, then we discard. Why? Because this traffic might be injected, okay, from outside. Okay, so we have to make sure that there is indeed a security policy match, and indeed the action for it is bypass. If it's IPsec, then we search the security association database. And in that case, don't say that we have to, if we don't, then we establish IKE. No, this is the exit point. So, yeah, so there should be, there must be a security association in the security association database. So if there is no match, then we discard على طول. Okay, and if there is a match, then we process the AH and ESP header, which means we have to perform the decryption. We have to perform the message authentication by generating the MAC, and then we verify, and once we do this, خلاص, we deliver back to the TCP layer or to the transport layer up. Logical, huh? Any question? طيب. So this is the window mechanism. The window mechanism, which is used for a anti-replay mitigation. So for anti-replay mitigation, so we have a window. So for any window technique, we have some packets before the window, okay? Some packets inside the window, and the packets inside the window are divided into two parts. There are some packets which are received, marked as received, and some packets are marked as not received, okay? And there are some packets, okay, which is supposed to be in the future, okay, which is after the window. Okay, typically IPsec uses a window of 64 packets, which means طبعا this is calculated experimentally. This means that IP is unreliable, as we all know. So anything within 64 packets is tolerated to be within the unordered delivery range. More than this, لا خلاص بقى يعني. So if we have this window and then we receive a packet here, this is clearly a replay attack. Okay, so we have to reject in that case. طبعا we have to reject, and of course there is a logic بقى. Just the fact that we reject, it doesn't mean that there is a logic to say that مثلا if this is repeated multiple times, then what do we do in that case? We have to declare بقى some security breach to that security association. Okay? So if that happens, then we have to renew this security association prematurely, even if it's not expired. Okay? So if we receive some packets here, then we can trigger this security association to be invalid, which means that we have to go through IKE again and renew the security association prematurely, even if the lifetime is not expired. Okay? So the logic is simple. So if a packet is received in the past, even if it's authenticated, okay, this might very likely be a replay attack. So we have to reject the packets. Okay? So that's simple. If a packet is received inside the window, okay, then we have two cases. Is this packet is received or this packet is not received? If this packet inside the window, the sequence number, يعني, if the sequence number is inside the window, but the packet is not received, then that makes sense. So this packet is in fact because of the unordered delivery. So if the packet is authenticated, then we accept it, we put it, and then we send it on. مفيش مشكلة. That's normal. If the packet is marked as received, okay, then remember IP is unreliable. Huh? IP is unreliable, which means that there is no possibility for retransmission. ماشي? So in that case, we also discard the packet and we mark it as يعني possibly يعني or likely a replay attack. Okay?
You
Type.
mean if it was received and then received again?
Yes.
There is the overflow to decide whether this is.
Yeah, of course. The logic behind the logic is that we have to use the sequence number and the counter overflow both.
Oh.
The counter overflow, remember, is just a flag. It's just a flag.
For what?
So if يعني what the purpose of this is like, what if I receive a packet here? Okay. I said before that this is يعني obviously before the window, so I should mark it as a replay attack, but that's not necessarily true. Why? Because maybe we have reached to the end of the sequence number and we have circulated the sequence number. So in fact, this packet is in fact a future packet. It's a new fresh packet. واضحة دي? Because there is a counter overflow. Right? So in that particular case, not only do I accept the packet, if I have a packet here, what do I do? What do you think I should do?
If I received
A packet here.
Outside the window
Mm-hmm.
in the future.
Mm-hmm.
Into
What do I do? Hmm?
I still didn't receive it, but why would I do anything? I didn't get the
لا ما هو يعني I'm receiving it. I'm receiving it.
But the sequence number belongs to that.
If the sequence number is n+1 or more, or n+2 or n+3, what do I do? What do you think?
Yes,
overflow counter.
No, overflow happens if you reach to the maximum number of 32 bits, 2 to the power 32.
Then it's a replay attack from the previous.
This is not replay attack. Replay attack happens for something in the past. What is the meaning of replay attack? Replay attack is that you store a packet which has already been sent and you replay it, صح?
Yes,
So this must happen for something in the past, not in the future.
it's like in the past circle or the past overflow. For example, if
Yeah,
this was-
overflow is different. Overflow, you are receiving a packet with a sequence number 2.2 to the power 32.
Yes.
Okay? 2 to the power 32 plus 1. Okay? You cannot store this in the sequence number. So you have to go back. But back here, this means that it's before the window, right? So there is an overflow, right? But in fact, it's not an old packet. This is a new packet. So, It's just that the sequence number has to circulate, right? So in general, what will happen if I receive a packet somewhere in the future? برافو عليكي يا والله ما شاء الله عليك ما شاء الله عليك يعني بصراحة there, and for any window mechanism there has to be a logic يعني for sliding the window. Okay, so for TCP or for يعني حتى for LLC, for logical link control, the logic was if I receive contiguous packets, if you remember, if I receive like 1 and then 3 and then 5 مثلا, and then I receive 2. Once I receive 2, then I slide the window. مثلا. Okay? Here, لا, it's different. The logic is that if you receive something in the future, that's definitely not a replay attack. Replay attack happens for something in the past, not something in the future. In the future, معناها you are receiving a packet that's authenticated, which means that the MAC is verifiable. Okay? And it's after the window. So this is a valid packet. It's definitely not a replay attack. Definitely. Okay? So you have to mark it as received, but all the packets that are marked as received have to be inside the window. So you slide the window. Okay? So n plus 1, n plus 2, n plus 3, you have to slide the window. Okay? And you mark it as received, and then the window will move. واضح اللوجيك؟ Okay, any question here? Sure.
If I have unreceived packet in the last or the old before.
That's fine because IP is unreliable. IP never guaranteed to deliver every single packet. Never promised anything about that.
So it's
Lost.
But
Fine.
then if I receive it later, I'll check for the other, for the sequence.
Attack in this case? If I
No.
Yes, but that should not happen within 64 packets. 64 packet is a pretty long window. يعني, that's why we have a window. That's exactly why we have a window. It's not just one packet. In TLS, we will see. For TLS, TCP in fact expects one packet ordered. صح؟ Only one packet. خلاص فالسيكونس نمبر هنا خلاص يعني السيكونس نمبر ما بيهركش. Anything below sequence number discard. Anything after the sequence number accept. خلاص وبعدين ايه sequence number plus 1. It's not sequence number plus 2. Why? Because underneath there is TCP guarantees everything. Guarantees reliability, guarantees order delivery, guarantees everything. So TLS job is يعني is easy.
So it can never happen to receive something out of the window scope.
ما فيش for TLS, as we will see, for TLS the window is just one item. There's no window. It's just here بقى.
For the IP,
For the IP. Okay.
No, I cannot receive. Yeah, it's impossible to receive something out of in the past outside of the window.
Yes. So if I slide the window, if I decide to slide the window here, مثلا, okay, and then I receive a packet here, and this packet is not received, okay, it's marked as not received. برضو I will discard it. I will not check whether it's received or not. I will discard it regardless.
Why?
Right? Why?
What if it's legit packaging?
It cannot be because the window in fact compensates or it makes up for how IP is unreliable. Okay, so if there is any packet here that's marked as not received, مثلا, okay, so that must be a replay attack regardless, or that's the logic that I'm going to use. It must be a replay attack regardless. Okay.
What if like this situation happens a lot? Like I keep receiving.
No, that's why we have a specific size for the window. We have 64 packets, and this is experimentally designed, or this number is designed based on some experiments. Okay, so this 64 is a pretty good number that there's no false alarms, يعني, or actually the minimum probability for the false alarms. Okay, which makes sense. يعني, if you have يعني, a packet outside the 64, this means that IP is not unreliable. IP is not working خالص يعني. It's totally out of sync يعني. It's not working يعني. ماشي. Any questions? I like these questions. This means that يعني people are yeah focusing يعني. طيب, so yeah, so there's nothing new here. So this tells you the transport level security, which secures host to host. So the tunnel in that case includes the host to host. And here I'm expecting to have ESP and then the original IP. Okay? And optionally, of course, in the middle there could be AH, right? But the original IP is maintained, is kept, is not. We can actually authenticate part of it only, but this is for authentication, not encryption. But we don't encrypt the original IP in any way, so it maintains the local and destination IP addresses at the beginning and the end of the tunnel, and that's it. Okay.
I'm confused a little bit. When to use ESP alone and when to use AH and when to use both together. I'm a bit confused in this.
Right. So let me just highlight it. So IPsec version 1, okay, uses ESP for encryption and uses AH for authentication. That's it. That's IP version. Okay? And you have to have ESP. You have to have AH. This chapter, in fact, details IPsec version 2 mainly. Okay? For IPsec version 2, you have ESP, okay, possibly for encryption and authentication. Possibly. Okay? So you can use ESP for both encryption and authentication. So you have one header for both encryption and authentication. Okay, which means that this header now will contain the security parameter index, and the security association corresponding to that contains all the algorithms that are used for encryption, all the algorithms that are used for authentication, the keys and everything. Okay? Which makes sense. Yani why bother? Yani why creating two headers? So in IPsec version 2, they thought, we can merge it. Okay? But what about AH? So IPsec version 2, okay, said, okay, so we'll keep AH, but we'll make it optional. Why? For backward compatibility. Okay, so for IPsec version 2, AH may or may not exist.
But ESP is...
ESP has to be there. ESP has to be there. And if AH is not there, this means that ESP is used for both encryption and authentication. واضح كده؟ واضح كده الموضوع؟ Clear?
There is a IPsec version 3.
There could be, I don't know. I'm not.
There is one of the diagrams. It contains IPsec version 3.
Right. Yeah. So there could be. There could be. And maybe this edition of the book is not updated for IPsec version 3. Maybe there could be some other features in IPsec version 3 that's not included here. But basically, these concepts are maintained even for IPsec version 3. I'm pretty sure. So they are still maintained. واضح? In the transport mode, which is what they call here virtual private network. So VPNs use VPNs between a host and a network, or a network and a network. Okay, it uses the tunnel mode. Okay, so for the tunnel mode, you have the IP of the router at the beginning of the tunnel and the end of the tunnel. So in that case, you have the payload, and then you have the original IP header, and then you add to that ESP and possibly AH, and then you have to add completely the outer IP. And this outer IP is going to include this IP for the source and destinations. ماشي كده? So that's this is mainly used for securing offices or securing private networks. ماشي. So again, this is this is يعني experience. طبعا I removed here, so this figure exists in the book. I removed here for IPv6 because it's way more complicated, and some of you don't have actually the background about IPv6 yet. So I removed from this figure the encapsulation for IPv6, so you don't have to know that. Okay. طيب. There is بقى ايه هنا there is a question. What is this? We didn't talk about trailers when it comes to network layer in general, صح؟ احنا قلنا in network 1 we always say data link layer is the only protocol that includes a trailer, and this trailer is used for frame check sequence, صح? Okay. But here we have some trailers. We have in fact 2 trailers. One of them is obvious. So if ESP is used for authentication, this is going to be the MAC. This is the MAC. MAC message authentication codes. Okay? So this means that we have to authenticate this whole part, including the ESP header. Okay? معناها ايه? We generate the signature for this whole part. Okay? And in fact, parts of the original IP address command. Parts of it. Okay? We generate the signature for this whole part, and then we encrypt that using the authentication key. ماشي كده؟ طيب. And then this is the MAC. What is بقى this ESP trailer? اللي هيقولها لي دي بقى يبقى يلا شيماء. It's your day today. Why do we have to have the ESP trailer here? Why do you think we have to have? So this is the MAC, واضح. Okay, but there is another placeholder here, ESP trailer. Okay, so this is a bit difficult. This is used for random padding. Remember, random padding was used for what? طب ما تقول انت لازم يبقى عندك ثقة كده. لازم يبقى في random padding. Random padding. Why do we use random padding? حد فاكر؟ Traffic analysis, to confuse traffic analysis, right? So the packet size, if the packet size is fixed in any way, this will give the attacker some information based on which he or she can perform traffic analysis and can attack or eavesdrop and can in fact recognize the key faster, right? So in all the protocols that we talked about and we will talk about, there should be random padding. This random padding is in fact like a dummy bits that gets added with a random size. But here we should store the size of the original payload without the random padding, so that we can recognize, okay, where the random bits start and discard them. واضح كده؟
Why do you call it the ESP? Why just simply call it the padding? Nothing to do with ESP, right?
لا هو it's related to security. It's related to security. So here we are using ESP for all security aspects, for encryption, for authentication, for everything, right?
So padding is part of ESP.
Yeah, padding is part of security, right? Okay. ماشي كده? And this exists here as well. So random padding is used to config analysis. Okay, so this is the transport mode. As I said, I explained this a lot. So so this is the encapsulation. So you will see by here in the case of tunnel mode, we have multiple levels of encapsulation, unfortunately. So so here definitely IPsec exists. It's for me it's actually, it should be above IP. Why? Because the header gets added before the IP. So in fact, logically, it should be above IP. So IP is underneath the IPsec or IPsec, yes. Okay, which means that the original IP header is not encrypted. That makes sense. Here بقى we have two levels of encapsulation in the network layer. Okay, so we have to have the ESP underneath the original IP header, okay, and we have to have the outer IP. So we have to have outer IP in order for routers to perform routing in the intermediate points inside the tunnel. ماشي? And of course the trailer and the MAC. ماشي كده? So yeah, so this is for ISP, so IPsec version 2. So for ESP with authentication in this approach, the first user applies ESP to the data to be protected and then appends the authentication data field. So the transport mode ESP. So so here ESP is used for both the encryption and authentication. But ESP itself can come as a transport mode or as a tunnel mode. So in the transport mode, the authentication and encryption apply to the IP payload delivered, but IP header is not protected, which makes sense. So the IP header itself is exposed. In the tunnel mode, authentication applies to the entire IP packet, including the payload and the IP header, and there is the inner IP packet and there is the outer IP header, which is in that case exposed. So nothing is in fact new here. This is the last part where we talk about the nested security association. So there is the concept of transport adjacency. Another way to apply authentication after encryption is use two bundled transport security associations. So the question here is that in IP, until this point, we talked about the fact that first we encrypt the payload or the payload and the header in case of the tunnel mode, and then we authenticate everything, صح? What happens if we do it the other way around? Is it possible? يعني first we do the authentication, which means that we generate the signature for the unencrypted packets. And then we encrypt. Okay? So, is there any preference for any of these? Generally, no. Okay? Yani here the book tried to advocate the fact that there is some advantage to the fact that you authenticate first before you encrypt, but that's not يعني a general rule. It's not a general rule. And in fact, if you encrypt first and then authenticate, or authenticate and then encrypt, both are fine. Okay?
For example, I encrypt, then I authenticate.
Right. So when you authenticate, you generate the signature for the encrypted packet.
So at the recipient part, it will do
the reverse authentication and then decryption. Yes.
Now, vice versa, if I do the encryption, the authentication first, that means I will hash. I'll create the hash. I'll hash the
for the unencrypted packet. صح?
Yeah, then I encrypt.
Then I encrypt. Okay. So what's the problem?
The recipient side. If I decrypt that, I'll get the hash. So how
if I decrypt,
at the recipient side, I will decrypt the packet. What will I get? I will get the hash of the packet. And how can I get the original data of the hash? I cannot get the original.
لا هو أنت الماc is not to be encrypted. MAC is not to be encrypted, and that's why it's included in the trailer. It's not to be encrypted.
Nothing.
Okay. لا, it's not to be encrypted.
So
whether you do the authentication first and then encryption, or encryption and then authentication, this يعني حتى we'll see in TLS and in SSH that we will discuss later. Both are fine. Both options are fine. There's no يعني preference. Okay, so
there are any cases that there are preferences, and is there any case that you have to do this?
هو هنا the book يعني, or here we will see يعني the author here tried to really advocate the fact that authentication, if you do authentication first before encryption, which is unlike what we have been discussing, because what we have been discussing is that we say first we add ASP, right, which means we encrypt, and then after that we add AH and we authenticate, صح? We kept saying that. Here بقى he's saying لا, this is not necessarily يعني the case. Which is true, IPsec itself can in fact have AH before ESP or ESP before AH, doesn't matter, right? But what I don't fully agree with is that he's trying to say that if we do AH first, there is some advantage to that. Okay? That's not, يعني, generally, it's not true. And it's not really the case. Yani. So we'll see that. So we apply authentication after encryption is to use two bundled transport security associations. So as we said, so we can have AH security association, and then we can have ESP on top of that, which means that we have like two tunnels, one for authentication and one for encryption. So in this case, ESP is used without its authentication option, and then encryption is applied. ماشي. EH is then applied in transport mode. The advantage of this approach is that the authentication covers more fields. So in that case, so the authentication here, if authentication is done after encryption, it may actually include also the ESP header and some other fields. The disadvantage is that the overhead of two security associations, and that exists, صح, مظبوط. If I use ESP with authentication, I have one security association, one tunnel, right? One security association for both. So I don't have to have two security association, one for ESP and one for AH, right? So there is an overhead associated to that. Transport tunnel bundle بقى, which this is يعني a bit even more complicated. So this means that we can technically have, so we can have the payload, okay, and then we add ESP in transport mode, okay, and then we have the original IP, and then after this we have AH after this, okay. If we do it the other way around, then in fact we need command to have outer IP. Okay? IPsec as a standard, it actually supports this, or it doesn't stop this from happening. So you could have two security associations, one in transport mode and one in tunnel mode. The standard allows this. ماشي? But remember, if you have to encrypt, if ESP is done in the tunnel mode, then you must have an outer IP header. You must have an outer IP header, right? Because of course, the original IP header will have been encrypted. So you have to have an outer IP. Okay? So that's about what I don't agree with. الحقيقة. So here he says that the use of authentication prior to encryption might be preferable for several reasons. It's impossible for anyone to intercept the message and alter the authentication data without detection, and that still exists even if you do the other way around. And it may be desirable. So it may be desirable to store authentication information with the message as the destination. بمعنى إيه؟ I received the packet, I decrypt it, okay? Then I authenticate the packet. Then what I could do is that I can store the packet and I can store the MAC, okay? So in case in the future I receive the same packet again, so in that case I can save in processing. Why would I have to do this? يعني why would, I mean, under which scenario would, يعني I receive the same packet again? In fact, لا, هو here he's saying that I'm receiving from the application. It's not a replay attack. So the application is sending the same packet twice, مثلا, or the same packet again. So in that case, he's saying that if he's receiving a similar packet, so it's like caching the packet. So this will speed up the process. But this scenario is It's very, very unlikely. Yeah. So in that case, I can store locally in the cache. I can store the same packet with the MAC. So when I receive the same packet again, if it's similar, then خلاص, I say, okay, so this is similar, so it's already authenticated. I don't have to verify the MAC again, yeah, something like that. Anyway, so yeah, this reason is not really a strong reason to say that authentication is preferable to be done before encryption. And in fact, you will see in later protocols that either way is fine. Authenticate first or encrypt first, doesn't matter. The most important thing is that you have to have both. ماشي؟
Doctor, I have a question.
تفضل.
As you mentioned before in previous slide, there is the ID could be encrypted, the half or
Part of it could be authenticated, not encrypted. I didn't say encrypted. Huh.
So it will be applied to outer IP or
Yeah, if it's the transport mode, if it's in the transport mode, then authentication can include parts of the outer IP. Yes, parts, only parts. Yes, only parts.
So outer IP
For authentication, not encryption.
So it will be not encrypted.
Yeah, of course, it's not encrypted in all cases. Outer IP cannot be encrypted. You have to have an IP header, okay, which is not encrypted. Otherwise, the routers cannot perform their functionality as well. Okay. So one approach is to use bundle consisting of an inner AH, which is the one that I'm talking about here. Inner AH transport and an outer ESP tunnel, or the other way around. So the standard actually allows all combinations to happen. Authentication in that case is applied to IP plus the IP header, okay? And then the resulting IP packet is then processed in the tunnel mode by ESP, which means that it gets back encrypted and so on, okay? How it looks like. So the standard allows all these scenarios to happen. And yes, this was your question earlier. So why would I want to have another tunnel on top of another tunnel? There are some cases. Why? Because if you have a tunnel here, okay, there is a security policy here. صح? This security policy may in fact bypass or create certain action based on the traffic, right? So if you try to access anything through that tunnel, your traffic might in fact be either completely blocked, صح?
Yes.
or bypassed. Okay? If it's bypassed, it's not secure. And if it's blocked, you're sad, طبعا. Okay? And that's in fact happens when we try to access مثلا some remote servers through Ooredoo network or through the university network. ماشي؟ يعني try to do WhatsApp مثلا on Ooredoo network. What will happen? WhatsApp call, yes, WhatsApp call. Have you tried that? Yeah? Okay, so when you use VPN, what will happen? It works perfectly, صح? Okay, so that's a perfect example for why you would want to have this. Okay? Another example that happens is that sometimes you want to force your application, and this happened to me one time. يعني you want your traffic to be secure, but whenever you try to send that traffic, it actually bypasses the tunnel for some reason, because of some security policy which is embedded in the VPN software. It happened to me once. So you want it to be secure. So if yes, so it's like you override. So if you're not going to secure it, I'm going to secure it. Okay? So these are scenarios really, which are practical scenarios through which you would want this to happen. Either because your traffic is blocked or your traffic is unnecessarily bypassed. Okay? So this example shows two security association. Okay, one for of course ESP and one for AH, and both of them are transport, which means host to host. Okay, so the local IP, destination IP exist, and the header is exposed, so routers can perform routing normally. This is, of course, also fine because this is a tunnel mode, and this uses only ESP for both encryption and authentication, and it's one tunnel, one security association, so life is good. Okay, so this is by one tunnel security association, and you have another tunnel of transport which goes inside that tunnel. So if you do this, this tunnel will not be able to identify this traffic at this point. Okay? So here, you will not be able to, so in that case, of course, there has to be a match in the security policy database. So this will match with the wild card that this is like default traffic, so just send it through the tunnel, secure, and that's it. Okay? But you don't apply any kind of a specific policy for that traffic because this traffic is not identified. And that scenario here talks about another example where you want to secure from transport. So you have a tunnel from a host to a network, and that uses the tunnel mode as well. Okay?
I have a question.
اتفضل.
This case 3, isn't
Here, case 4.
No, case 3.
Case 3, okay.
The previous one. Isn't this considered a security breach in perspective to the security gateway?
Security breach?
Yeah, because from their perspective, I want to block this.
لا
block
هو
this.
لا
I can hide my traffic
hiding is not
from the
hiding لا هو remember لا
Same
remember
what I've
لا
done
لا لا
with Orido
لا
and
لا remember what is the original objective of IPsec? Securing network infrastructure. Okay, if you want to hide your traffic, that's fine. I can use for your case I can use firewalls. ماشي? I can use firewall rules, which is part of system level security, and we'll talk about this in the last chapter, to possibly block VPN مثلا. You can block that VPN. In that case, firewalls, they can work on all layers at the same time. ماشي? But IPsec, remember, IPsec is for securing network infrastructure. So hiding your traffic, خلاص, hide your traffic, that's fine. You will not affect my network infrastructure anyway. But if I want to stop you, I can. صح? So I can have a rule through firewall مثلا to block any VPN. I can do that. That's another story يعني. But Orido طبعا they cannot do this easily يعني. ماشي? They cannot do this easily because this traffic is not identified. The service is not identifiable. The service. You cannot see that this is in fact a WhatsApp call. You cannot see that. Because it's encrypted. So you cannot see that. So Orido, in that case, they will be puzzled. If they stop the traffic, that might get them into trouble يعني. صح? So this is a tunnel mode, okay? And there is a transport mode tunnel for host-to-host security, which uses two bundled security association, one for ESP and one for AH, okay, which goes through a tunnel mode from. So remember, host to a network, it uses a tunnel mode. So the transport mode is only used for host-to-host. Why? Because the source IP and the destination IP are maintained, okay, which means that the original IP header has to be exposed, okay? Yes, there is no need for outer IP header. So in that case, we can use the transport mode. Any other combination, you have to use the tunnel mode because you're not maintaining the source IP and destination IP in the header. So you have to have an outer header. Okay, so that can be done only using the tunnel mode. Any questions? Any questions so far? خلاص كده؟ احنا we'll stop here عشان يعني برضو الناس we'll stop here. So because this is IKE, so we'll discuss IKE for user authentication and key distribution. We'll discuss it next time, inshallah.